Next, directions. Question number 6 to 10. Constituents of sun rays received in 1 minute. So, in 1 minute, so the sun rays what they have received, based on that the data they have given. Okay, total sun rays received in 1 minute is equal to 3600 units. So, in a single minute, we are receiving 3600 units of sun rays. Among the 3600 units, 15% are radio waves, 10% are alpha rays, 20% are UV rays, 10% are IR, 5% beta rays, 5% gamma rays, and maximum is 30%, that is X-ray. So, the 3600 units are bifurcated into these parts, 30% that is X-ray. Now, if the human body can withstand a maximum of 9720 units of IR rays, okay, see here actually in 1 minute we are receiving only 3600, but in the question what they are telling, if the human body can withstand a maximum of 9720 units of IR rays, means only IR rays we can withstand a maximum of 9720 units when exposed to the sun continuously. Then what is the maximum time in minutes that a person could stand in a sun without crossing the threshold limit of IR rays? Means, so per minute how much IR rays we can receive. Okay, based on that, to receive 9720 units of IR rays, how much minutes we have to stand in the sun rays? Very simple. Now, total units what we are receiving is 3600. So, total units is 3600. Among these 3600, so 10% is IR rays 10%. Now, what is the actual IR rays we are going to receive in 1 minute? That is 10% of 3600, which is equal to 360. So, per minute we can receive 360 units, but we can receive 9720 units, okay, in the sun rays continuously. So, 1 minute 360 units. So, how many minutes it is required to collect 9720 units? Okay. So, after cross multiplication, 360 into x is equal to 9720. Very simple. Few people are there who will do directly, that is 9720 by 360. You people also can do like that. Okay. Just for the explanation sake, I am telling in detail. Okay. So, x is equal to 9720 by 360. So, you simplify. So, 36 you got, in the numerator you have 972. So, how many times? See, both are divisible by 12, I believe. The denominator is divisible by 12, but how about the numerator? 12, if the numerator has to be divisible by 12, then it should be divisible by both 4 and 3. 72 is divisible by 4. How about this one, 3? Yes, 972, 9 plus 2, 11 plus 7, 18 is divisible by 3, therefore it is divisible by 12. So, 12 8s are 96, 1 carry over, 12 1s are 12. So, 12 3s are 36. Now, 3 2s are 6, 3 7s are 21. So, you got 27 as answer, means you can stand 27 minutes continuously under the sun rays to receive at 9720 units of IR rays. Okay. So, 10% is the IR rays. Per minute we are going to receive 360 units, then we have to receive 9720 units. Then how much time we have to stand under the sun rays? That is 27 minutes. So, option C is the right answer. Option C is the right answer. So, 9720 by 360. So, option C 27 minutes is the right answer. Okay. Let us go to the next problem. Problem number 7. Problem number 7. The amount of beta rays in 10 minutes of sun rays is how many times the amount of IR rays in 3 minutes of sun rays? See here, the amount of beta rays in 10 minutes of sun rays is how many times the amount of IR rays in 3 minutes of sun rays? You have to calculate the beta rays in 10 minutes, how much we are going to get, and we have to calculate the IR rays in 3 minutes, how much we are going to get. See here, per minute we are going to get 5%. See, for this problem we have two methodologies to solve. If we use these two methodologies, then See, the first methodology is the general methodology what we take to follow, but the second methodology is a fantastic method. Directly you can solve, within 10 seconds you are going to get the answer. Okay, see here, 5% is the beta raise, so that is calculated on 3600. So 5% on 3600, how much you are going to get? 10% means 360, 5% means half of 360, that is 180. Next, IR raise is calculated on 3600. IR raise means how many percentage? 10 percentage. 10 percentage means 360. But this has to be calculated for 10 minutes, so which is equal to 1800, and this has to be calculated for 3 minutes, which is equal to 3. So 6 3s are 18, 1 carry, 3 3s are 9 plus 1 10, so 1080. So how many times it will be? 1800 divided by 1080. So now you have to solve. Okay, so it takes too much time. See here, 180 by 108. So 180 by 108, how much you are going to get? 12 9s are 108, 12 1s are 12, 12 5s are 60, 15 by 9. So 9 1s are 9, 6 carry over, 9 6s are 54, 9 6s are 54, approximately equal to 1.67. Approximately equal to 1.67. So this is the traditional method. Okay, so your answer is 1.67. This is the traditional method. We have one more method, a fantastic method. Directly you will get the answer. See here, how much time you have to calculate? 5% is calculated on 3600. So it's a common number for both the two, so you will neglect the 3600 into 10 minutes. So altogether you are getting 50%. Next, IR raise 10%. So 3 minutes. So altogether you are going to get 30%. Next, you have to calculate how many times. So that is 50% by 30%. So 3 by 5. So 3 1s are 3, 3 6s are 18, 3 6s are 18, approximately equal to 1.67. See how easy it is. 5%, 10 minutes, so altogether 50%, 10%, 3 minutes, altogether 30%. So how many times? So 50 by 30, 5 by 3, after simplification 1.66, approximately equal to 1.67. Max to max 5 seconds, not more than that. Okay, so 1.67, option C is the right answer. Option C is the right answer. Okay, so let's move on to the next problem, problem number 8. How many minutes of exposure to the sun in a day would be enough to ensure that the body receives enough amount of vitamin D, given that the body requires 40 unit of vitamin D every day and that 30 unit of beta rays generate 1 unit of vitamin D. See, 30 unit of beta rays generate 1 unit of vitamin D, but you want 40 units of vitamin per day. So what they are asking, how many minutes of the exposure to the sun in a day is required. So how many minutes you have to stand in front of the day to receive 40 units of vitamin D. So that is very, very important. See here, beta rays, that is 5%. So 5% on 3600. So 10% 360, 5% 180, 5% 180. So 180 means per minute you are getting 180 units. Okay, means 30 unit of beta rays is equal to 1 unit of vitamin D. 30 unit of beta rays is equal to 1 unit of vitamin D. 1 unit of vitamin D. Now 180 units we can receive in 1 minute, means how many units of vitamin D we are going to get? 180 by 30, so 3 6 are 18. So 6 units of vitamin D. 6 units of vitamin D we can receive in 1 minute, but we should get 40 units, therefore 40 by 6. 6 6 are 36. Okay, so 6 6 are 36. What is the remainder? 4 is the remainder. 6 4 by 6. So 2 2s are 4, 2 3s are 6, which is equal to 6 2 by 3. 6 2 by 3. Since 5% of 3600, that is 180, means per minute we can receive 180 units of vitamin D per minute. But in the question they have given that 30 unit of beta rays can generate 1 unit of vitamin D, means 180 divided by 30, 6 units of vitamin D, means per unit we can receive 6 units of vitamin D. Then to receive 40 units of vitamin D, how much time is required? 40 by 6, that is 6 4 by 6. So after simplification we are going to get 6 2 by 3, therefore 6 2 by 3 is the answer. Option D is the right answer. Very simple to calculate. Okay, let's move on to the next problem. Problem number 9. The amount of alpha rays received in 2 minutes is how much more or less than the amount of radio waves received in 4 minutes. So alpha rays per minute, how much you are receiving? You are receiving 10% per minute. Alpha rays per minute you are receiving 10%. So 2 minutes 20%. Next, radio waves per minute, how much you can receive the radio waves? 15%. Like that, how minutes? 4 minutes. So 15 into 4, 60 minutes. And what they are asking you? They are asking that how much more or less than the amount. They are not asking us to calculate the percentage more or percentage less. They are simply asking us to calculate how many units more or less. Okay, so 60% minus 20%. Alpha rays received in 2 minutes is how much more or less than the amount of radio waves, that is 20%, which is equal to 40%. So 40% on 3600. So how you calculate? 50% minus 10% you do, otherwise you go with 10% into 4. So 40%, 50% minus 10%. So what is 50%? 3600 by 2, that is 1800, minus 10%, that is 360. So how much you are going to get? 40. Next 7 minus 3, 4, 1440 units less, because alpha we are comparing with radio waves. Alpha rays is less than radio waves by 1440 units. Okay, so 1440 units less. Very simple. Per minute 10%. So for 2 minutes it is 20%. Radio waves per minute it is 15%. For 4 minutes it is 60%. So subtraction is equal to 40%. So 1440 units less is the answer. Very simple to calculate. Actually speaking, this problem was appeared in the PO exam. See, pie chart, very simple problems you can get. Okay, so 9th problem, 1440 units less. Okay, let's move on to the next problem, problem number 10. Problem number 10. If presently the ozone layer in the atmosphere reflects away 60% of the sun rays, then what would be the amount of gamma rays received in 1 minute if the ozone layer were completely disappear? See here what they are telling. Presently ozone layer is sending back 60% of the sun rays, means Earth is receiving only 40% of the sun rays. So 40%, see here, 60% of the sun rays the ozone layer is sending back. So we are receiving only 40% of the sun rays. We are receiving only 40% of the sun rays. So the data what they have given is, see here, 40% of sun rays, 40% of sun rays, that is X, is equal to 3600. Then what is the total sun rays? 4 9s are 36. X is equal to 900 into 10. 900 into 10, which is equal to 9000. Which is equal to 9000. So without ozone layer, we are going to receive 9000 units of sun rays in 1 minute. So how much gamma rays we can receive? Gamma rays is 5%. So gamma rays is 5%. So that is 5% on 9000. 5% on 9000. That is 450. 10% is 900, 5% is half of 900, that is 450. So option D, 450 is the right answer. Option D, 450 is the right answer. Okay, let's move on to the next problem, problem number 11.